Okay, if f of x is blah blah blah, find the following in simplest form. So we're plugging a bunch of things into a function, or in some cases putting things outside of a function with various effects. So when they give you f of 2, what I want you to notice is originally this had an x in it. That x has been replaced with a 2. That's what they want us to do. They want us to take this whole expression, but everywhere it used to have an x in it, put 2 instead. So x squared becomes 2 squared, 4x becomes 4 2's, and the 5, which doesn't even mention x, isn't affected. A 5 is a 5 no matter what kind of function it's in. Okay, so every x has been morphed into a 2. Technically, this would be enough, but you're generally expected to finish these if you can. So 2 squared is 4, 4 times 2 is 8, plus 5, 4 plus 8 is 12, plus 5 is 17. So if they give you a function with just a number inside it, your answer should end up just being a number. In an example like this, where they give you a function with x inside it, your result is going to contain x's. This one just says, do 2 times this entire function, meaning 2 times, I encourage the use of brackets here. It's hard to use too many brackets, and you can very easily hurt yourself by not having enough. 2 times the entire f of x, and we can pretty that up a bit. That's 2x squared plus 8x plus 10. Different thing this time. Now, where the x used to be, up here in the original, they're saying put 2x instead. So instead of x squared from our original function, we're now doing 2x squared. And instead of plus 4x, we're now doing 4 times 2x. And again, the 5 is unaffected by all this. Can we clean that up? Yeah, we can. This is 2x times 2x, which is 4x squared. 4 times 2x is 8x, and we still have our 5. And there's no like terms in there, so that's the best we can do with that expression. Now, in D, they say, write out your entire expression, x squared plus 4x plus 5, and after that, subtract 2. That can be simplified with the greatest of ease. On to the next one. This is not too nice. Everywhere that there used to be an x, put x minus 2 instead. So where we used to have x squared, we now have this thing squared. Where we used to have plus 4x, we now have plus 4 this thing. And then we have our stolid plus 5 that ignores all this stuff. Can we clean that up? Yeah, a little more work, but we take x minus 2 and FOIL it. You go x minus 2 times x minus 2, you get x squared minus 4x plus 4. Then you do 4 times x, and 4 times negative 2, and there's our plus 5. What does that clean up to? X squared minus 4x plus 4x. They cancel out. That doesn't always happen, but every so often. 4 minus 8 is negative 4. Negative 4 plus 5 is plus 1. There we are. And finally, f of negative x. Everywhere there used to be a plain old x, put negative x in its place. So now instead of x squared, we have negative x squared. Instead of 4x, we have 4 times negative x. Make sure you have brackets on this, or it'll look like 4 take away x, and you'll get flaky answers. And our plus 5. Now, funny thing happens here. Negative x times negative x just gives you x squared. So on the first term, this negative has no effect. But it does affect the second term. There you get minus 4x, and the last term doesn't change at all. So the x squared didn't even notice when we switched its x with a negative x, but the middle term did. And then the 5 didn't notice either because it doesn't care what x is. It's just a fixed number.